The overall goal of this procedure is to functionalize polyethylene glycol and peptides with methacrylate groups for subsequent chain polymerizations and hydrogel synthesis. This is accomplished by first combining methacrylic anhydride and the unfunctionalized precursor in a scintillation vial. The second step is to use microwave energy to functionalize the PEG or peptide. Next, the PEG-DM is dissolved in dichloromethane, or the peptide is cleaved from the resin and all side chain protecting groups are removed in an acid-based cocktail. The final step is to precipitate the PEG-DM or methacrylamide functionalized peptide in ether. Ultimately, proton NMR or MALDI time of flight mass spectrometry is used to show successful functionalization of the PEG or peptide macromers.
Hi, my name is Amy Van Hove. I'm a PhD student in the Department of Biomedical Engineering at the University of Rochester. The main advantage of this technique over existing methods, like reacting PEG with methacrylic chloride, is that the reaction is significantly faster and more environmentally friendly.
Hi, my name is Brandon Wilson. I'm an undergraduate in chemical engineering at the University of Rochester. This method can help answer key questions in the biomaterials field, such as how hydrogels produced using PEG dimethacrylate can be employed to control the delivery of therapeutic cells and molecules.
Hi, I'm Danielle Benoit, an assistant professor in the Department of Biomedical Engineering at the University of Rochester. The implications of this technique are for developing therapies for a variety of diseases, as the synthesized compounds can be used for cell and drug delivery applications.
Prior to starting this